Okay, let's have a look at this question then. James and Debbie have some buttons. If James gives Debbie 36 buttons, they will each have the same number of buttons. If Debbie gives James 16 buttons, then the ratio of Debbie's buttons to James's buttons will be 3:7. And the question we're asked is, how many buttons did James have at the start? Okay, well, what we have here is two different scenarios really, and it's by, I think, drawing them both and looking at the information we get from both that we're going to solve to find the answer, basically, to solve this problem. So, right, we've got James and we've got Debbie. James and Debbie. And we're told that if James gives Debbie 36 buttons, they will each have the same number of buttons. So we're going to draw a bar. Okay, let's say, there we go. That's what Debbie has. And this is what we're going to give James. Okay. And James has this much more than Debbie. Okay, that's the difference. Actually, what I'm going to do here, this is our question, isn't it? We're going to keep an eye on our question. How many buttons did James have at the start? This is our question. Okay. So we have here a difference between James and Debbie. And we're told that if James gives Debbie 36 buttons, they'll each have the same number of buttons. Now, once you, this sort of question comes up in bar models quite a lot. This scenario that if A gives B a certain amount, then A and B will have an equal number. And what you quickly learn when drawing them out is that means that half of the difference has to be given. Okay, so if James gives this amount to Debbie, okay, then she will have, then her bar will be this big. James will lose this bit, and that will be added on to Debbie's. Okay, and that amount we know is 36. Okay, so we then know that the original difference also between Debbie and James must have been twice 36, okay, which is 72. All right, so that's what we learn from this first scenario, from this bit of information given here. So let's now draw this second scenario. If Debbie gives James 16 buttons, and the ratio of Debbie's buttons to James's buttons will be 3:7. Right, I'm still going to draw it so with James and Debbie this way round, but we're going to have, now this bar, by the way, this one is drawn, the scale of it is there's nothing significant about the size of this bar compared to the size of this one. Okay, so what have we got? We've got 3 here, and then, so we've got 3, 4, 5, 6, 7. Okay, right, so this would be the end scenario, the 3 to 7. And that happens if Debbie gives James 16 buttons. So Debbie must have had a few more. Okay, here. 16, and this 16 was given to James. So that's what this was what it looked like before Debbie gave the buttons to James. So what do we know about that? Because we know that in the original scenario before here, we know that there was a difference of 72 between James and Debbie. Well, where can we draw that here? Well, if Debbie doesn't give 16 buttons to Debbie, well, then she would have up to here, okay? And before James acquires these 16, he has up to there. So we know that the difference here is 72, okay? Which means that we can calculate. Now, the reason we like this scenario that we have here is we have equal parts, don't we? All right. We know that all of these parts, if I draw them in, so we know that all of these parts are equal. And you'll get very excited about these equal parts when we're drawing bar models. Okay, so this final scenario finally gives us some equal parts. So how can we fill in the numbers? Well, the difference here is 72. So, but we want to find out this difference so that we can calculate the value of the individual parts. And this difference must be 72 add the 16 times 2, which is 32, or you could just add 16 and 16, obviously. So 72 add 32, which equals 104. So we now know that the difference between here and here is 104, and that is equal to 4 of these parts, 4 of these equal size parts. So we need 104, we need to divide that by 4, and that gives us 26. So now we know the value of each of these parts. So 26, 26, and I could keep drawing them. Okay, so what does that tell us? Well, what we can now do is calculate, well, we can calculate what James has now. What does James have? He has 7 parts. We're told that here. Well, 1, 2, 3, 4, 5, 6, 7. Okay, so 26 times 7 gives us 182. Okay, that is, so that's this, 182. But that's not what James had at the start. What James had at the start, actually should have probably have drawn it in on this scenario as well. What James had at the start was this. Okay, so that again is our question mark. Okay, and that must be then the 182 minus the 16. That's here. Okay, so we need 182 subtract 16, and that is 166. So that is how many buttons James had at the start, 166. All right, I hope that helps.